Hello, welcome to Business Reporter's Industrial Innovations campaign. I'm Ashley Blake. Tech giants seem to champion autonomous production, self-driving cars, lights-out factories, smart logistics and transportation. Indeed, most businesses need these solutions, and many of them want to develop their own autonomous systems. Meanwhile, these organisations find the implementation expensive and complex. But the development of bespoke solutions are affordable, says Neil Mottram from Cambridge Consultants, a global AI and automation tech firm. So how can businesses build their solution? This is what we're going to discuss. Neil, welcome to Business Reporter's Industrial Innovations campaign. So the pandemic caused unprecedented worldwide change to supply chains and consumer buying habits. The buzzword that we're hearing is business automation, but many companies have yet to embrace business automation. Why do you think that is?
Disruption creates opportunity, and that opportunity is causing companies to look at automation and autonomy in ways that they've never thought of before. But there's also a bit of a barrier. Traditionally, some systems cost a lot of money to develop there. We've come up with a solution that reduces the cost and the time of that development by 100 times.
I see. So what makes innovation in automation and autonomy so expensive?
It comes down to intelligence. Intelligence requires training, and training requires data. And traditionally, acquiring that data is a time-consuming and expensive process because it's done in the real world. What we're doing is to start creating a lot of that data in the simulated world, something we call synthetic data. And in doing so, you massively reduce the time and the cost. So if you had 100 images in the real world, what we're doing in the synthetic world is only requiring one of those and then augmenting that real world data with synthetic data. So you fill in the blanks that you no longer need to have on that real world data. And in doing so, massively increase the speed and reduce the cost of the development. There's some clever mathematics that we employ that compare that synthetic data created in the simulation to the real images that would be captured by a camera, say. And by proving that the equivalence is the same, you have the confidence that that synthetic data is every bit as good as real-world data that you had to collect previously.
Fully trusted?
Fully trusted.
So let's talk about the process. How do you create virtual simulations for businesses in different industries?
So we go about it from a modular approach. There's no one size fits all, and therefore you can't just take something off the shelf and shoehorn it in. You need to start from first principles, which is what our system does. So it's built of different building blocks. Think of it like Lego. And much like Lego, you can rearrange those building blocks to create a range of different solutions that are fully tailored to a particular use case and a particular company. And in doing so, you have something that is not only a better fit, but is also unique. It offers competitive advantage. It also allows us to test out certain sensors that no other simulation in the world can do. So we have the ability to simulate radar sensors, for example. That's important because it's a low-cost alternative to LiDAR. And at the moment, the cost of LiDAR is a barrier for a lot of autonomous vehicles becoming commercial reality. By being able to simulate the performance of low-cost alternatives, we enable a whole range of different companies and a whole range of different technologies to come to market. It also allows you to try what were called what-if scenarios. So here we are in August. If I'm wanting to train my autonomous car for winter and the snow, I can't wait until January for the snow to arrive. I want to do that development now. I can do that in the simulated world. I can test out for those different environmental conditions. I can also test for potentially dangerous conditions. We know of situations where autonomous vehicles in the real world haven't recognized humans crossing the street with tragic consequences. You don't want to have those kind of situations in the real world. Let's try them out in the virtual world where the consequence of getting it wrong is minimal.
I see. Looking at this in a bit of detail, people tend to use the terms such as automated and autonomous. What's the difference between them, and which one do you provide?
So we view it as a continuum. There's automation at one end and autonomy at another. And they're both linked. You need to be able to automate certain processes before you can create an autonomous system. Let's take an example in agriculture. The farmer who's driving a tractor today isn't really there to steer the vehicle. The vehicle can navigate autonomously. They're really there to look over their shoulder and seeing what's happening behind, whether they're planting, whether they're harvesting, etc. They're using their experience to know what good looks like and then adjusting something in the tractor accordingly. You need to be able to automate all of those small steps first before you can create the fully autonomous system, before the farmer is no longer spending their time driving and is actually spending their time on much more productive activities. It's kind of augmenting their day. So those little automation steps build up into a collective whole that allows autonomy to be realised.
I see. And finally, Neil, what are the barriers for development and implementation that this technology is removing?
So we like to think of this as levelling the playing field. Today, particularly on the autonomous end of that spectrum, it's really only big tech that has the pockets deep enough to create those systems. If we move into a synthetic and simulated environment where it's 100 times cheaper and 100 times faster, suddenly companies in a whole range of different industries can realise their ambitions in autonomy and automation. Whether they're in construction or logistics or indeed in farming or on a port, suddenly this modular approach allows companies to realise their ambitions and gain competitive advantage at the same time.
Neil Mottram, Cambridge Consultants.